okay, so we're carrying on with this equilibrium paper. So let's just go through this again. So what does that mean? What does it mean actually? Reversible reaction. The reaction is going backwards and forwards. What's this delta H? Delta H is change in enthalpy. What did we say enthalpy was? Another way of saying heat or energy. Right. This minus or this negative sign tells you the forward reaction. So we're going to write this down, yeah. The forward reaction is exothermic. Right. So we need to state two features of a dynamic equilibrium reaction. Right, there's a few things that we need to learn. If we learn all of them, it's fine. Right, there's a few things you need to know. We'll write all three from down. The forward and reverse or backward reaction occur at the same time or simultaneously at the same time. Just learn it this way. The next bit is, and you've got to put the word rate. The rate of forward reaction equals the rate of backward reaction or reverse reaction. And the last one that you need to know is, so they've asked for two, but we're going to put all three in case they give you one. So number 3, I'm going to write up here. And the concentration of reactants and products remains the same. Right, don't make the mistake of saying that they are equal. They're not. It remains the same. Right, it remains, they're not equal, it remains the same. Just remember that. So put this word in, don't put equals there, they remain the same. Right, how would a decrease in temperature at constant pressure affect the amount of methanol produced? Right, we've now got to go back to this. So look, there's the inequality, there's the equilibrium sign. So if we look on the, let's look at this here. The negative indicates an exothermic, so this is the hot side and this is the cold side. This is what exothermic. Now on the other side, we've got 1 mole of this plus 2 moles of this gives 1 mole of this. 1 mole. Right, so if you look carefully, let's use that. You have 3 moles here and 1 mole here, so that is 1 mole. this has got more moles or more particles flying about, so it's got a higher pressure. This side will be then therefore low pressure. So just bear that in mind. We've split the thing into products and reactants. It's a bit busy, but let's have a look. How would a decrease in temperature affect the amount of methanol in the equilibrium mixture? Right, so do you know what they're trying to say here is which way would the equilibrium shift? Right, which direction? Does it go left or does it go right? If it goes left, you get less product, right, or less yield. If it goes this side, you've got more product, more yield. Right, so decrease in temperature at constant pressure affect the amount of methanol. So what happens? If you decrease the temperature, the system will go to the side with the higher temperature, so it'll shift. Right there. So this is the hot side. So the system, once you've made it cooler, it wants to become hotter, so it'll shift this way. So we'll say the amount of methanol, or yield in this case, increases because why? The forward reaction is what? Exothermic. So it wants to go to the warm side because you made it cooler. It wants to do the opposite. How would an increase in pressure? So they've increased the pressure this time. So what we do is we go up. It wants to go to the low pressure side. So this is high pressure. This is low pressure. Right. This is low pressure because it's got fewer molecules. It's only got one, and this has got three. So the system will go to the low pressure side. The system will go to the low pressure side. Why? Because, so it's a 2 marker, so because there are less or fewer moles or molecules. We'll just stick to moles. There are few moles. You just say put it on the right hand side. Right hand side A. There you go. That's it. Done. Methanol. Remember we said the OH group tells you that it's an, that's a U by the way, it's an alcohol. Right. The OH minus ion is responsible for making things alkaline in nature. Yep. The H plus ion it makes something acidic. Right. So we need to write a chemical equation to convert methanol into methanal. methanol into methanal. A mixture of methanol and oxygen. So methanol, they've given you that, plus water, oh, not water, oxygen. It's passed over an iron oxide catalyst at 250 and you end up with methanal, which is there, plus, what did it say, and water. That was the easy part. Now we need to balance it. We've got 4 hydrogens. We've got 4 hydrogens there. We've got 3 oxygens. We've got 3 oxygen. Oh, I can't copy. My fault. Because I was trying to get this balanced and it wasn't balancing. Right, okay, so let's try that again. So 1, 2, 3, 1. So right, I'm looking at the carbon, 1 carbon, 1 carbon, 3, 4 hydrogens, 2, 4 hydrogens, 1, 2, 3 oxygens. I've got 2 oxygens here. So if I double this, I've now got 2 times 3 oxygens plus 1, that's 3, and then I've got 2 here plus this 1. Right, but now what's happened is my hydrogens have increased. 2, 4, 6. I've got 6 on this side because 2 times 2, and I've got 4 here. No, sorry, 3. So if I here, if I double that CH3, so that I've got 3, 4, 8 here. I've got 2, 4, 8 here, so I need to double that because now, right, let me get this right. So 2 carbons, 2 carbons, that's fine. Carbon sorted. I've got 3, 4 times 2, 8 hydrogens. I've got 2 times 2, which is 4. 2 times 2, which is 4. So I've got 8 hydrogens. So the hydrogens balance. So let's get rid of that. Right, and then now let's look at oxygens. We've got 2 oxygens, 4 oxygens. We've got 2 oxygens. We've got 4 oxygens. So that balances. Okay, so that's balanced. What is meant by the term catalyst? Right, I like to learn it like this, and then I just write everything down. It just covers anything, because if you misread the question and they want you to know or explain a bit further, you've thrown it in, so it's not a problem. Is a substance that increases the rate of reaction. Right, by providing an alternative route for the reaction with a lower activation energy and probably the best way to do it is to write it like this: chemically unchanged at the end, yeah, once the reaction's finished. So if you can write all this down, it'll cover any angle. Explain how a catalyst works. Right. Now this is what I'm saying. Look, we've done it, and this is the root, this is the mechanism. So now we can write that bit down here. It provides an alternative route for the reaction with a lower activation energy. Okay, there you go. Methanol, combustion of methanol. So we know methanol, they gave us that CH3OH plus combustion is with oxygen, and you get carbon dioxide and water. And we need to balance those. And when we balance those, by the time you've balanced it, you will get this. Let's have a look. 2 carbons, 2 carbons. 3, 4, 4 times 2 is 8. 4 times 2 is 8. 8 hydrogens. Oxygen, we've got 2 oxygens. 3 times 2 is 6, so that's 8. 2 times 2 is 4. 4 oxygens there, so 8 and 8, so it balances out. Right, okay. Done. The hydrogen needed for the manufacture of ammonia is made by a process called steam reforming. In this process, a mixture of methane and steam is passed. Right. Let's do that same thing again. What we're gonna do is we're gonna analyze this. I know it's long-winded, but what it does, the repetition, then it allows you to hopefully do it independently. So you try it. So the first thing we can look at is this plus for delta H. So what did we say delta H was? Change in enthalpy. Because it's positive, the reaction, the forward reaction is endothermic. Right, interesting. That's that done. So we know this side is the cold side, and this, relatively speaking, is the hot side. Then we jump on to, let's get rid of that. Then we jump on to another color. Let's try that color. Right, okay. Then we jump onto the number of moles. So you've got 1 mole here, or 1 molecule, 1 mole or molecule here. I'm not looking at the atoms. I'm looking at this number here in front. Yeah, and that's a 1 and that's a 1. So altogether we've got 2. We've got 1 here and 3 here. Right. It's a molecule or it's a mole, however you want to see it, just as a particle. But so we've got 4 here, so I know straight away this has got more moles or more particles, so it's the high pressure. This will be low pressure. Right. Right, the same reaction. Predict whether a low or high temperature would produce the highest yield. Yield is product. So we want, let's take, can we take that color? Okay, we want to be on this side. That will give us the highest yield. We want to be on the right hand side. So this is the cold side. So if we use a low temperature, the system will move to the if we use a high temperature, the system will move to the cold side it decreases. So we want a use a not hot hot temperature, because the system will go to the cold side, right? Now what do we mean by that? Because the forward reaction is endothermic. Yeah. So we're going to use high temperature or hot temperature. Right, the same thing here. They're saying give a reason whether high or low pressure. So we want to be on the yellow side. That's got high pressure. So what we need to do is we need to use low pressure. Why? Because the right hand side or the product side, the right hand side has less or fewer moles and has a lower pressure, and that's it. Explain how catalyst increases the rate of reaction. Right, so it's the same. Look, if you can see this bit here, it's the same thing. It provides an alternative route for the reaction with a low activation energy. So there's two parts to that. So it provides an alternative route for the reaction with a lower activation energy. Right. Okay. Some of the carbon monoxide is removed in another reaction. This reaction, carbon monoxide is mixed with water, steam. Right. It is reversible. So we notice that straight away. So we're saying carbon monoxide is CO. Carbon monoxide is that, and carbon dioxide is that. So plus water will give so carbon dioxide is produced, so we want CO2, right, plus something, because we've got hydrogen here, so that's what it looks like it's going to produce. And that's it. It's balanced because we've got two hydrogens, two oxygens, one carbon, right? Explain why why the carbon monoxide is oxidized. Right, because carbon monoxide gains an oxygen. There you go. Right, okay, look. it looks weird, but if you read it, carbon dioxide produced can be removed. So we know we've got carbon dioxide by passing it through a solution of potassium carbonate. So we're going to add potassium carbonate, and then water. It's a reaction, and you're going to end up with potassium hydrogen carbonate. So it gives KHCO3. And now we need to balance it. So 1 carbon, 2 carbons, 1 carbon, so we put 2 there. We've got 2 potassiums, we've got 2 potassiums. We've got 2, 5, 6 oxygens, we've got 2 times 3 oxygens. And we've got 2 hydrogens, and we've got 2 hydrogens. So it balances. That balances. Right, okay. We'll call it quits there on this one.